Hello, my name is Chad Williams. I'm a lab instructor for AFE 245 with Dr. Golson in 2017. Today, I had a lab and we're talking about results, but we really don't have enough time in lab to go through everything I wanted to, so I decided to make this video in order to do that. I'm going to try and skip over a lot of fine details with the intent of making this shorter so that you can kind of just follow along and do things. But of course, if you have questions or want to know more of the conceptual side of what's going on, you can talk to me or your lab instructor or Dr. Golson, who will be more than happy to help you along. So what I want to accomplish here is to demonstrate how to make figures. Later we're going to talk about tables and demonstrate how to do tables, and then do a few t-tests, so your statistics, as well as we're going to quickly talk about how you report your results. So the first thing we're going to do is create figures, and the way we do that is we need to calculate our means and our standard deviation. So what you see on the left here is I have my day 1, 2, 3, 4 with a baseline, my two groups, with each line being a participant. So you might not have a baseline, and that's okay. So for what I talk about, if I use the baseline, you might want to just use day 1 instead of the baseline. Baseline is basically they did the task prior to any practice. So I only have 7 people per group just because that's what my lab has. We have 14 people, but that might be different for you guys too. What I learned is the most common t-tests that people are planning are to compare each group on day 4. So basically, is the mass group different from the distributed group? So is one performing better than the other? So that's t-test 1. Other t-tests that are common is looking at within a group, so just looking at mass, for example, and seeing if their day 4 is different from their day or their baseline. So did they improve at all during the whole thing? And so you're going to do that for one group, then you're going to do it separately for another group. So that's what I'm going to talk about today, a t-test on day 4 between the two groups, and then a comparison of day 4 to baseline for each group separately. Okay, so again, I find the best way to start is doing your mean and standard deviation. The reason for that is to do figures, and figures can tell you a lot about your data already. One thing to note is that I made up all this data here, so that's just numbers that I threw in at random, or semi-randomly at least. So whatever I come out with today is just by chance. So with Excel, you can use functions by starting with the equal sign. So with mean, the function is average. So equals average. Then we're going to grab the masked baseline. Okay, so I'm in the mask group. You can't really see it there, but the top row is the mask group, and then the baseline day. So I'm going to hit enter. Okay, so I'm going to make this a little bit bigger so we can see it happen later. So I'm going to do again average, but this time for the distributed group. So distributed baseline, the average. There you go. Now if you don't know this trick, basically you can pull this across now, and what it's going to do is it's going to take each next column. So you see on day 2, now it's looking at the day 2 column. So what I have there is my mean for every day and the baseline for each group. Now I'm going to do the same thing with standard deviation. So stdev.s, S stands for sample. That's because we're using samples here. So we've collected just a proportion of people out of the entirety of everybody. So again, for the masked baseline group, I'm going to collect those individuals. Then for the standard deviation, for the distributed, same deal. And then I'm going to pull them all across here. Okay, so we're also going to do confidence intervals. So equals confidence.t. I won't talk about what t means today. What it asks for is 3 different things here. So it asks for alpha, a standard deviation, and a size. So the alpha is always going to be 0.05 in this class, and in most psychology it's 0.05. Again, I'm not going to get into the dynamics of why this is, or really what it means, but basically when we do a t-test we end up with a p-value, and for us to call two things differently, so on day 4 for example, for us to say that mass is different from distributed, the p-value that we get has to be below 0.05. So that's what we use conventionally in psychology, as well as most, if not all sciences. So that's what we're going to use here. The standard deviation for the mass baseline group is up here. We just calculated it. And then our size is the size of people in that group. So here we have 7 people in that group. Okay, so 7. So again, I can pull it across, and then I get my confidence interval for each group on each day. Now what's different here is actually I can pull it down as well. So what happens, just like earlier I was saying, the first one, if you drag it across to the right, it moves from this column here, when you drag it to the right, to the next column. It's going to move from this standard deviation to the next row. So if I drag it down, it's going to be the next row. So that corresponds to distributed baseline. So the next thing we're going to do is we're going to plot the figures. Now I'm going to talk about max and min CIs later when we're doing tables. So to do a figure, basically I'm going to grab all of this here. So that includes the baseline, day 1, day 4, and both groups as well. I'm going to go insert, and then this here. Now I'm using a Mac obviously, but that is generally the same for Windows, but it might be a little bit differently. I'm not sure about other systems like Linux, but I think generally they're constructed similarly. So what happens is now we have a figure. So we have baseline, day 1, day 2, day 3, day 4. Then we have our mass groups in blue, and then distribute in orange. What I see here, even though, like I said, I kind of made up the data, is things are increasing over time. It looks like, at least. Now, statistically with t-test, we're going to determine if that's true. The next thing we're going to do is we're going to put error bars on this. Now, standard deviation is an error bar, but it's more commonly used to use confidence intervals. So what I'm going to do is I'm going to double-click the blue. Okay. Now, if I go up to format or chart design, I have this add chart element. So I'm going to click that, go to error bars, and more error bars options. Okay, so what I'm going to end up using is this confidence interval thing that we calculated here. So again, error bars, more error bar options brings up this. We're going to actually put our own custom values in there, and I'm going to specify those values based on this row here. So you see positive and negative error value. We're going to actually use the same numbers for both. So I'm going to click this button. Then, because we're looking at blue, which is the mass, we're going to highlight this top row. Okay, and then the negative one, I'm going to do the exact same thing. I'm going to hit OK. So now these error bars represent confidence intervals. You see those? But it's only on the blue one. So now I'm going to double click the orange one and do the same thing. But then with the bottom row, because that's our distributed row. Okay, insert that there, and then that one there. Cool, so now I have my error bars on top of my mean. So the top of each of these bars is, of course, your mean, and then we have our confidence intervals around it. Now, I'm not going to tell you too much about APA, because that is basically something you're going to have to do on your own. You can use the website Owl Purdue, so owl like the bird, Purdue, and that has a lot of APA style stuff. I'll give you a couple pointers based on what I see here. First thing you saw me there, just remove the title. You're going to have a caption below it later, so you don't need a title. It'll be in your caption. I'm going to delete these horizontal lines. All I did there was I clicked on the lines, I'm hitting the delete button. I'm going to move my legend. You might have to play around with your legend. And then I'm going to move it to the top there. I'm going to, what can I do here? No. I'm going to add axis titles. So just like where we got the error bars, we have axis titles. So I want a vertical one. I'm going to call this reaction time. So in brackets, I put S for seconds. That's very important. So if you have a unit of measurement, put it in there, like milliseconds, seconds. Some people have like counts. So how many times did you shoot a basketball in a hoop? That doesn't have a unit of measurement. It's just a frequency count. So you don't have to have something in brackets there. And then I'm going to put a axis title on the bottom here too. We could call that sessions or whatever you want to call it. You don't have to have these specific names either, day 1, day 4, whatever. Do what you want there. Now you notice that this is a little bit high up here, so I'm going to actually pull this down a bit. So there we go. So there's a brief, probably not completely APA, but well on its way version of the figure you're going to use. So again, add a caption. What a caption is basically a short description of what they're seeing here. So there's our figure. These are descriptive statistics. So there's a difference between descriptive and inferential statistics. Descriptive just basically says what's happening. So in the mass baseline, we have a mean and a standard deviation or confidence interval. And we're going to talk about this a bit more when we're making a table, because our table will be filled with descriptive statistics. So just this and that, for example. Actually, we're going to calculate something else here. So descriptive is just describing, hence the name, what's happening in that group at that time. Inferential statistics, on the other hand, it's comparing two things. So like I was saying before, we're going to do Ttests. So comparing day 4 between the two groups. And so with the T-test, we're going to determine whether those two groups are actually different from each other statistically. So let's start doing some T-tests now. So now we have a figure, we have some mean, standard deviation, confidence intervals, and let's do some T-tests. So the first T-test I'm going to do is, I guess, day 4 dependent samples T-test. And let me write the other ones as well. So masked group independent samples T-test. And I'll tell you what those dependent and independent means in a second here. And then distributed group independent samples T-test. Okay, so I'm going to put those there. I'm going to actually give myself a little more room here. Do a column for P value and one for a T value. Okay, so day 4, dependent samples T-test is going to compare masked versus distributed on day 4. The masked group independent samples T-test is going to compare baseline to day 4 to see if there's any change in performance. So hopefully they've learned something over those 4 days. And then distributed is also going to look at the distributed and whether they've learned something in the 4 days. Now it might already be becoming clear what dependent and independent samples means, but basically, actually I mixed those up. This is independent, sorry about that. Independent, these are dependent. Cool. So day 4, independent means that the two samples are two different groups of people. So I'm looking at a group that did a mass practice versus a group that did distributed practice. But a dependent, on the other hand, is when you're looking at the same person at two different times. So in this analysis here, we're going to be looking at this person or these people on baseline time and day 4 time. So again, a dependent samples t-test is when you're looking at the same person at multiple times, while the independent is two different groups at the same time. Okay? Now, independent and dependent, there's a lot of ways of saying this. So different words are used, and we're going to see while we're doing t-tests. So we're going to start with this day 4. So we're going to compare this group to this group on day 4. We're going to hit equals t.test. See, that comes up pretty easily. And that's for 4 different things here. Array 1 is going to be the first group, comma, array 2, comma. So tails doesn't say here, but you have 2 options, 1 or 2. 1 being one-tailed, 2 being two-tailed. We're going to use two-tailed, and I'm not going to tell you why. That gets into more specifics of statistics. That's kind of out of the scope of this. But if you have questions or want to know why, let me know. So type here, so it's up here now, but type is asking if it's independent or dependent. Independent is 2 samples, while dependent is paired. So here we're using independent samples, which is number 2. So here I'm going to hit 2, and that's in Windows it'll say 2 samples with equal variance. Okay, and there's our t-test. So let's look into this a little bit closer. What you see is my value is 0.002. So earlier I said that it has to be below 0.05. That was our alpha for our confidence interval. So what this means is that this value is actually significant. So these 2 groups are significantly different on day 4. Okay? And that's because it's below this number. Perfect. So we could do the same with the other ones, but it's going to be slightly different, but equals t.test again. But this time we're going to be comparing baseline for mast with day 4 for mast with 2 tails again, always 2 tails. But this time we're going to be using a dependent or paired sample. So this is going to be 1 instead of 2. So here what you see is, again, there's actually a significant difference. So it looks like training really did help the mass group. Or I guess practice did. So the last one, we're going to do the same thing for distributed. So there we go, comma, there you go. 2 tails, paired sample. And yet again, this one's a lot closer to 0.05, but it is still under 0.05, so it is statistically significant. Okay, so these are our p-values that we're going to report. Okay, but we also need to report our t-values. So what are our t-values? So t-inf is a way to turn a p-value into a t-value. So we're going to put our p-value here, and our degrees of freedom for this is going to be 12. Now I'm going to have to explain what degrees of freedom is, but I'm not going to get into the conceptual side of things. But what's important here is that we're taking n minus 2, okay? Now what I mean by n is how many people in this group, or in this whole sample. So we have 14 people in total, and we're going to take minus 2 because there's 2 different groups, and that's going to be our degrees of freedom. So you notice that's 12, so 14 minus 2 groups is 12. Now, that's not necessarily the best way to describe it, but I think that's going to be good enough for here. That way you guys can kind of understand what I'm saying without really getting into the dynamics behind it. Now, Tn for the dependent samples group is a little bit different. So we still have our p-value, but our degrees of freedom is actually going to be 6. The reason that is because in this one we actually only have 7 people, but only one group, so 7 minus 1. So our degrees of freedom is 6. Then we're going to do this tinv again with the probability, comma 6. Okay, and that's because, again, there's only 7 people here, and then there's only one group, so 7 minus 1 equals 6. So we have our t values and our p values, okay? And you know what? While we're at it, I'm going to add a degrees of freedom just to remind ourselves later, and this one was 12 again, this one was 6 and 6. Okay, so what we have now is we have our data, we have our means, our standard deviations that are confidence intervals, we have our figure that's started, but you guys are going to have to finish it with things like captions, and we have 3 Ttests done. So there's 2 other things that we need to do. We need to first report our statistics, but we also have to do tables. So the next step we're going to do is we're going to create a table. Now, I'm going to do this in Word, so forgive me for not having it open already, and I'll take a sec here to open because my computer is a little bit slow. But we're going to create a table in Word. Okay, so I'm just going to create a new document, let it load. We're going to use it with just a standard table, if you're familiar with Word, that is. So I'm going to go Insert, Table. I have to think for a sec here because I don't know how many columns. You can always add columns later, but I have, I think so baseline, day 1, day 2, day 3, day 4. Just kind of ignore me for a sec here. Then I need 12. Yeah, so I'm going to have to add more here. Let's do this for now. So what we're going to do, I'm going to have to add at least one row. We're going to figure this out as we go. That's okay. So what I'm going to have is my mass group, and then my distributed group. And I'm going to have my mean, CI, for my baseline. Then day 1, it'll get less confusing soon. Day 2, day 3, day 4, and I'm going to have to add another one here. Insert a column to the right. Okay, so I'm going to have mean and confidence interval. Okay, so what I have is my mass group and my distributed group, and their means on baseline. Their CIs on baseline, and then same thing for day 1, day 2. So what I'm actually going to do to organize this a bit better, so I'm going to go here, I'm going to highlight these 2, and I'm going to say merge cells. Then I'm going to actually put all of this, I'm going to center all of it. So I'm going to also merge cells here, merge cells there, merge cells there. There we go. So now you see baselines here, day 1's here, day 2's there, 3 and 4. Okay. The next thing I'm going to do is actually, so earlier I said that figures have captions below it. Tables have captions above it. So I'm actually going to insert a row above, and I'm going to just merge the whole thing. I'm going to say table 1, and then insert caption here. I'm not going to insert a caption. You know what? Let's do a little bit. Descriptive, dix for mass and distributed practice groups for 4 days of practice and a baseline. Yeah, so you have to add more like what CI means, for example. So you have to say things like, so this shows like there's a mean and confidence interval, CI equals confidence interval, blah, blah, blah. I'm going to let you guys be more creative about that rather than doing it all for you. The next thing I'm going to do is I'm going to talk about the layout a bit. So we're going to go to these borders thing here. I'm actually going to just take out all this border. Actually, I should have done it here too. So no more borders, but that obviously gets confusing. But I'm going to insert some. So here, we're going to add one above it. And then we're going to add one below it. Bottom border, there we go. We're going to add one on the bottom as well. There we go. So now suddenly we have our baseline, day 1, day 2, day 3, day 4 with mean and CI. So what we have here is a bunch of empty spots here. So APA is all, even though it might feel weird, it's double spaced. So let's add double space now. So that's a little better. It's a little more out there. So I'm going to leave that. So again, this is going to be APA style. For example, this should be italicized. You're going to have to look at that on Alaperdu yourself. So what I have over here is our means, and over here is our table. We do have confidence intervals, but we're going to do the max and min of those, and I'll tell you what that means in a bit here. So let's look at the baseline, for example. So the mean of the baseline for the mass group was 3.285. Let me see if I can zoom in there. Oops, sorry, mean of the base is 3.285, blah, blah, blah. So we're going to just do it to 2 decimal points, so 3.29. So that's this one here, okay? The mean for this one is 5.57. Do you see where I got that number? Right there. So then again, we're going to just go to day 1 now. So 3.57, 6.29. So the next thing we need to do is put the confidence intervals. But what we're going to do is we're actually going to calculate the max and the min. So I haven't actually told you what confidence intervals are yet. And that's okay. I'm not going to get too far into it. But basically, I was talking about populations and samples earlier. So when we have a sample, it's just a proportion of a population. So if I'm talking about all EFE 245 students right now, so everyone in your class, that would be my population. So I technically could measure everyone in that population and get, for example, a mean height for everyone there. So I could technically measure our population height in that class. However, we're usually trying to predict much larger populations, for example, the human race or everyone in North America, and it quickly becomes impossible to measure every single person. So we try and estimate what every single person is based on a sample, okay? So a confidence interval is the degree to which, or it's a range of numbers where we believe that the actual population mean height would be, for example. So if we're talking about height. So we're trying to estimate what the population mean is from the mean that we get in our sample. And let me do a couple calculations here, then we'll talk about what that means in a sec. So our max CI, so confidence interval, is basically just our mean plus the CI, okay? So again, I can drag that this way and that way. And then, of course, our min is the opposite. So mean minus CI. Okay, so now we have all these ranges, and oops. what these ranges correspond to is actually these top and bottoms here. So if we were to match these numbers, which I won't do right now, well, actually, sure, why not? 1.8, that's about 1.8 there, or it is 1.8 there because it calculated it for us, or we added it for it there. And then 3.13 for this one, for the min, that's 3.13. So basically, I was talking about what a confidence interval is earlier. Let's look at it a little bit closer to here. So our mean reaction time for the baseline in the mass group here is this column right here, or the top of this bar. But being a sample, this might not accurately represent the population. So maybe if we're talking about, I guess, height, maybe for some reason we accidentally only sampled a bunch of basketball players. Now, on average, I believe basketball players are a little bit taller, or a lot taller than the average person in North America, for example. So that might mean that we're a little bit wrong. So we might have an average that's higher than it should be. So here we put our confidence intervals, and basically what we're saying is, even though our sample average is here, we believe that the population of all North America, or EFE245, or whatever you're talking about, that mean should be somewhere in here. Now, obviously, the smaller this error bar is, the more certain we are with how close our mean is to it. But basically, even though our sample mean is here, we're not 100% sure that that truly reflects the population. So we put this error bar to determine, how, what's the range of possibilities that the population mean is in. So I could tell you more about it if you're interested. But basically, that's all I'm going to tell you right now for this. But of course, you can talk to me or approach other people with questions. So now what we're going to do is we have our confidence intervals here, but we're actually going to put our max and min in instead of just the CI. So here I could have put this number here, so mass baseline. I could have put 1.48 and I'm done, but I'm rather going to put the 1.80 space 4.777. So you have your, put a comma there, your mass, the mean, and then the confidence interval min and max. Okay? You can do the same thing with distributed. So again, we have our distributed here, so the min being 3.13, comma, and the max is 8.01. There we go. That's what each one should look like. So baseline, so we have our mean and our min and max of standard deviation, min and max, or not standard deviation, but confidence interval. And you can do that for baseline, you can do that for day 1, day 2, day 3, day 4. So you're going to end up, so that's just a proportion there with all these filled out. So these are your descriptive statistics where we have our mean and our confidence intervals, and the confidence intervals being the min and the max. So of course, because we took the mean minus confidence interval and plus confidence interval, these should be around that number. So one's below it and one's above it, is what I mean. Okay, so a lot of what I showed you with this table is APA style. So for example, the lines here, so you shouldn't have any vertical lines. It should be double spaced. These should obviously go all the way across when you have all your data in there. But again, be aware that Alpert is going to tell you exactly what you should be doing here, and you can figure it out there. But there is some helpful tips here. So even though the table is incomplete, what we've done so far is we have our raw data, we've calculated all of our things here, all our descriptives, we have a figure that we created, and now we've started creating a table and you can fill out the rest. What I haven't taught you, and we also did some Ttest here. What I have not taught you yet is the how to report this stuff, but I actually haven't even talked about how to do an effect size. So let's talk about Cohens D right now. So I'm going to insert a couple of rows here, just move things over. I'm going to write Cohens D. So I'm going to kind of figure this out as I go. So again, excuse me if I kind of mix up some things. Basically, what an effect size is assuming there's a difference between groups, or between groups or between conditions. How big is that difference? So essentially, we have two means, but with an effect size, we're trying to determine how much of a difference there is between these groups, and not based on their mean, but like how much of an effect does mass undistributed have. So with a p-value, you can say, yes, there is an effect, but we don't know how much influence that effect has. But a CohensD is essentially doing the same thing, but it's going to be not from 0 to 100, but it's going to be in standard deviation units. So these are standard deviation units up here, which means how many standard deviations is one group away from the other. Okay? Now, if you don't know what standard deviation units are, it's basically how far someone is from the mean. So if this is your mean and someone scores here, they're, let's say, 2 standard deviations above the mean. But if they score here, they're 1 standard deviation below the mean, which means that they are not too far apart, but obviously the further you are, so like 6 standard deviations above the mean means you're way higher than the mean. So with this mean here, so let's create a bar for the sake of this explanation here. Let's call this our mean value. So let's say that mean value is 100 for this group, so group 1. And then our next value for group 2 is here. So let's say, do another color. I don't know if I'm even making sense right now, but let's say it's 110. And this is group 2. So there are 2 standard deviations above, which is a pretty big difference than just 1 standard deviation. Okay? Yeah, it probably doesn't make too much sense, but again, talk to others about, or like your instructors about what that really means. So we're going to do a Cohens D, and there's actually 2 different ways to do this depending on the independent samples, the independent or dependent samples. So let's actually start with the dependent samples because it's actually a lot easier. So what I'm going to do is I'm going to create a new column called difference. So this difference is going to be day 4. So sorry, earlier I said you can put equals and call up functions, for example. Here I'm going to do equals, but I'm going to actually just pull one of these numbers, hit the minus, then do baseline. I guess I did that over here with confidence intervals, but never explained that that was a thing. So you always have to start with equals, okay? So I did this minus this. Okay, and I have that difference there. I'm going to pull it all the way down. I'm going to color code it so I don't confuse myself because I'm easily confused. So that's the distributed group, while this is the masked group. I use that color. Cool. So we're going to calculate a Cohens D here. Let's start off with the masked group. So a Cohens D is simply the mean difference divided by the standard deviation difference. So what that means is I'm going to get this mean and standard deviation. I'm going to split this up a little bit more. So this mean is just going to be the average of the difference. Okay? And standard deviation is just going to be the standard deviation sample of this difference. Cool. So Cohens D for the masked group is going to be this mean divided by, so you just use a slash for divided by, this standard deviation. So our CohensD here is 1.16. So the distributed group, the day 4 is 1.16 standard deviation higher than the baseline. Okay, so let's do the same thing here. This equals average of the differences, and then standard deviation of the differences. And then we're going to equal this mean divided by standard deviation. So for the distributed group, it's 1 standard deviation higher. So day 4 is 1 standard deviation higher than the baseline. So what that means is that both groups improved, as we see here, but this group actually improved a little bit less. Now, I'm not going to talk about that too much. I could talk about why that is and why it looks a little different in our figure, but I won't. So basically what we did is we created 2 CohensDs here. That's for the dependent sample. So dependent is fairly easy because you could just do one minus the other. Basically you could just end up with this new column of difference values and calculate it there. Now to do the dependent or independent sample CohensD is a little bit harder, and this is what you have to do here. Now don't get freaked out about this. It's actually fairly simple. I'm just showing you very slightly how to do it. So it's one mean minus the other mean divided by the standard deviation pooled. Now the standard deviation pooled is this, which again, don't worry about it. But simplified is this. So we have a standard deviation, we square it, plus the other standard deviation, squared it, divided by 2. So let's do that now. Okay, and we square root the whole thing. All right, so the first thing we want to do is we want to get the means of day 4 for each group, which is actually right here. So these 2 means, okay? So let's do it side by side. So what we want is mean 1 is here, mean 2 is there. And we want to do one minus the other. Okay, so I'm going to call this top part because it's the top part. Okay, so equals this one minus this one. And that's that one minus that one. Perfect, no problem. Bottom part, or standard deviation pooled, is standard deviation squared plus standard deviation squared divided by 2. So our 2 standard deviations are here and here. So this one squared plus this one squared divided by 2. So let's start off by saying this to the power of 2. Now I'll tell you how I did that in a sec here. Then we're going to do the second one. So that and that one now. So this to the power of 2. Okay, so to do the power of 2, it's shift 6, so this little hat guy, okay, and that just means squared, right? So right now I have my standard deviation squared for both groups. So to get that together, I have to add them together, so equals that plus that. That gives me this part here. Now I want to divide that by 2. So now I have this, I want to divide it by 2. So this divided by 2. Cool, which gives me this whole entire thing here. And I want to square root that. Now there's a square root function, and so it's SQRT. Okay, we're going to square root this number here. So again, what I did is I have my standard deviations here, as you see, okay? Standard deviation 1 and standard deviation 2. And then I started off by just squaring it. So I get these 2 values. Once I have the 2 values squared, I added them together. okay, as you see here. Then I divided that by 2, so I get the middle. Then I have the whole square root thing. So what that gave me is this bottom part, so this final answer gave me this part, which is the bottom here. So to get my D now, what I'm going to do is I'm going to put it up here where my thing is, the top part divided by the bottom part. Now my Cohens D is negative 2.04. Okay. Now, hopefully that wasn't too confusing. I think it should be okay. The reason it's negative is the direction I did it. So basically what that's saying is the mass group is 2 standard deviations below the distributed group. Okay, so I could have easily done it backwards where I did the distributed group minus the mass group and it would be positive. So what's important there is that you realize which group is higher than the other, and you could easily see that with this. So the distributed group has a higher day 4 than the mass group does, right? So what we have now is our p-value, t-value, degrees of freedom, and Cohens D. So what we can do now, maybe I'll label this, so Cohens D for independent samples. It's always good to label stuff so you know what it is later. So let's see what we have. Again, we have our raw data, we have our descriptive statistics, we have our figure, we have our inferential statistics, and we have a table of descriptive statistics. So the next thing we have to do is report all of it. So in your results section, what you have to do is you have to talk about what these things are. And then you have to describe what you found. So in krigolsonteaching.com, there's a part where, I don't know, it says like this is how how to write a paper, and it talks about all these things. What Dr. Grigolson writes is that each Ttest should have its own paragraph, but it should have 2 specific sentences. Basically, one saying what the difference was, and then one talking about the test. So let's start off with that. So let's look at this one here. Okay, so this is the independent sample, so we're comparing day 4 for the mass and distributed. So results, and you could write this in many different ways. I'm just going to write something really quick here. So my first sentence is just describing in plain words what we found. So results demonstrated that the distributed group performed better on the final day than the masked group. Specifically, so now we're going to talk about the test itself. So first we say what test we use. So we already wrote it here. An independent, samples Ttest revealed that the distributed scores, or distributed group scores, were higher than the masked group scores on the post-test of day 4. I should write that out. I'm going to put a comma there, so I'm going to change this from post-test but to just test, or post-practice tests, because that's on day 4. Now what do we have to write here? We actually have to write these things formally. So I'm going to zoom in and actually put it down here first. So we're going to start off with T because we use a Ttest. So it's a shortcut for a Ttest. We're going to put in brackets. So T actually has to be minuscule and it actually has to be italicized. And we're going to put our degrees of freedom in here. So here we calculated it was 12, okay? Brackets, space, so even a space matters here, equals space, your T value. So that's this value here. Okay, so our T value we're going to round to 2 decimal points, so 3.83, comma. Then we're going to report our P value. So you put italicized P, again minuscule, space equals space. This one you do to 4 decimal points and you drop the first 0. So it's actually 0.0024. It's 0.0024. So it's actually customary to remove that first 0 and report to 4 decimal places. Now, what you might get confused is when you're reading KrugolsonTeaching.com, how to write a paper, he does talk about how it's customary to use like P less, here let me do it separately, so maybe otherwise I could write P less than 0.001 or something like that. That's no longer actually accepted. You actually have to report the exact P value now, and in the rubric that we're going to post, you're going to see that that is actually one of the criteria, is to actually report the actual statistic there. So what we have is we have our T value here, we have our degrees of freedom, we have our test, and we have our P value. Okay, so comma, again italicized minuscule D for Cohen's D. Why it's called D, I'm actually not too sure, but a guy named Cohen determined that. Equals minus 2.04. Or I guess 0.5. Okay, so now I have my t-test, my p-value, and my confidence interval. So I'm going to attach this to my actual paragraph now. And there we go. There we go. Results demonstrate that the distributed group performed better on the final day than the mass group. Now, what's important here is the word better. I could use a better word than better, but I'm showing a direction. So one group had higher performance than the other group. Now, if you don't find significant differences, you could say there were no differences between each group. But if there are differences, you have to determine, or you have to state what that difference was. Which group is higher than the other group, or which group is lower than the other group. One pet peeve of mine is when people write, results demonstrated that the distributed group performed better, period. You actually have to say then what. So here, I wrote then the mass group. That's actually important. You do have to report that. That's just a pet peeve, and that's just English rather than like APA style. But don't just stop at one, this group performed better or something like that. But you have to say better than what. Okay, so again, don't forget independent or dependent samples here. T-test revealed that the distributed group scores were higher than the mass group scores on the post-practice test of day 4. Now, one thing I didn't put, which I'm going to put now, is some descriptive statistics in here. Actually, sorry, I'm going to zoom back in there. I'm going to put italicized capital M and little d. I'm going to get that right out of the way. Equals. And this d I'm actually going to make a subscript, such as that. What this means is mean difference. Okay, so what that means is we're going to look at the difference between the means of day 4 here. So we calculated that right here. So the mean difference is minus 2.43. Oh, should not be italicized. There we go. Then in our in square brackets, we're going to put confidence intervals. So I haven't calculated confidence intervals here, and I won't for the time being. But you can write the confidence intervals here, and that would be something like 1.33 space 3.45 or whatever. So again, I didn't show you how to calculate that, but figure that out on your own. So what we have here to put it all together is you're higher in the mass group scores on the practice tests of day 4, blah, blah, blah. Mean difference is negative 2.43 with those. Oh, these should be negative as well because it should be surrounding this number with your t-value and then your p-value and your Cohens D. So your t-value can also be negative and should be in this case. So basically, it depends how you report it. Again, and that depends on the direction that I did it here. So because I chose that it was this one minus this one, they're all going to be negative because this one's a lower number than that. But I could have reversed it. And reversing would just do the opposite, so it would become positive for everything. So your t-test wouldn't change except for the fact that, or your t-value wouldn't change except for the fact that it's positive now. Your Cohens D, same thing. It would still be the same distance, but positive. It's usually, depending on what you're talking about, but positive's an easier way to report it. And you see here, I even said that they performed better, that this group had higher rates. So these should be positive because I'm talking about how something did better. If I said instead they performed worse, then it should be negative to follow that trend. Sorry, that was an oversight while I was doing this. It's kind of obvious. I'm just kind of doing this as I'm going, so I don't have too much of a plan, so I keep making mistakes. But I think generally you're getting what you want out of it here. So what we have is our results demonstrated, blah, blah, blah. So, more common tongue without getting too specific. Then we talk about what tests we used, and then we talk about all our statistics here. So again, we have our mean difference with confidence intervals, which you're going to have to figure out how to do. Again, we can help you with that. We have our t-value, our p-value, and our effect size. So to wrap up, we started off with these raw scores from our two groups in our day. We were able to calculate a bunch of different descriptive statistics, created a plot, then we did some t-tests and calculated Cohens D. Then we put them all in here. One other thing I'll say before we finish off here is you have to refer to your figures and stuff, so you can say something like descriptive statistics can be found in table 1 and illustrated in figure 1. Then of course with that you have to include such things in your Word document, so don't attach these separately. So copy, paste. So this should say like figure 1, blah, blah, blah. And then you can do that there, and of course finish your table, and there is generally your results. Of course you have your other paragraphs too that also describe what else tests you did. So we're just talking about one test here. We're going to talk about all 3 t-tests that we calculated already. Cool. Thanks. Sorry that probably dragged on really long, and I could have done it a lot more streamlined, but that's what you get. Hopefully it helps. Let us know if you have any questions, which you probably will, but hopefully that's a good start to guiding you. Cool, thanks.